Uh, Hello everyone, my name is Kirti Tijare, and today me and my friends are going to explain about the modern file systems. Today we are going to learn about an important part of operating system, something that helps the system store, organize and manage all our data. Many people know about files and folders, but few understand how an operating system actually keeps track of this information in the background. So in this presentation, we will explore about how file system works, how it manages our data safely, and how it provides quick access whenever we need it. We will look for the old systems like FAT, which we still find in USB drives, to modern ones like NTFS, ext4, and BTRFS, which are used in Windows and Linux. We'll even look at how these systems ensure that our data remains safe even when something goes wrong. So, first, what is a file system? So, what exactly is a file system? It is a method used by the operating system to store, organize, and find data on a storage device such as hard drive, SSD, or USB. So, we can think of it as a translator that connects human readable commands like openreport.pdf to actual ones and zeros on the disk. Without a file system, our computer wouldn't know how to find or save your files correctly. So, the core responsibilities of file system are: first, the namespace. This means it helps organize files in a tree-like structure with folders and subfolders. Next, metadata management. This system stores information about every data: who created it, when it was last changed, its size, permission, and where it's stored on the disk. Next is the data management. It keeps track of which parts of the disk are used and which are free, so data doesn't get mixed up or lost. Last is the API. This system provides a way for programs to open, read, or write files easily using commands like open, read, and write. In short, the file system acts like a manager that takes care of both the logical side and the physical side. So, next, the core concepts. Next is core concepts. To understand modern file systems, we need to know the two more core concepts: indexed allocation and generalized. First is index allocation. It is the method used in Linux and Mac OS through a structure called an inode. An inode stores all the details about a file, such as its size, permission, owner, and timestamp. However, instead of storing the actual file data, the inode contains pointers that tell the system where the data blocks are located on the disk. This makes the file system very flexible and efficient. For example, renaming a file or creating a shortcut becomes very fast because only the metadata changes, not the actual data. So the next is the journaling. Journaling helps prevent data loss or corruption if something goes wrong, like a sudden power cut. When a change is about to happen, the file system first records that change in special log called a journal. After that, it performs the real update. If the system crashes, the journal helps it know what was happening and allows it to recover safely. This ensures atomicity, meaning the operation either finishes completely or not at all. This feature makes modern file systems much more reliable. So the next is the legacy system file. It is one of the oldest file systems still used today, which stands for File Allocation Table. We'll find FAT on most USB flash drives and SD cards. It works in very simple way. At the start of the drive, there is a table that keeps track of which block of the disk belong to which file. Each file has an entry pointing to its first block, and each block then points to the next one, like a link chain. The computer follows this chain from one block to another until it reaches the end of the file. So the pros and cons of legacy file system are: first, advantages. It's very simple and easy to use. It's lightweight and works with almost every operating system, whether Windows, Mac OS, or cameras. Then cons of file. It has no journaling. So if you remove a USB drive while it's writing data, the file can easily get corrupted. Next is it offers no security, means there are no permissions or ownership options. Then it has poor performance because files can become scattered on the disk, making it slow. It has a 4 GB file size limit, which makes it unsuitable for storing large modern files like videos. Because of these limitations, CAT is still used for small storage devices but not for main operating system anymore. So the next part will be explained by my next member Sakshi.
Hello everyone, I am Aditya Dabade and
Hello everyone, I am Sakshi Tambe. Now I will be continue the next topic, that is Windows Standard NTFS. Uh, now let's look at the system used by Windows. It's called NTFS. It stands for a New Technology File System. NTFS is used in almost all modern Windows version from Windows XP up to Windows 11. The heart of the NTFS is something called as master file table, that is MFT. You can think of MFT is a big database that keeps records of every file and folder on the drive. In NTFS, everything is treated as a file. Even the system has their own data files, that is called as the metadata, is stored as a hidden file. It's a very fast because small files can even be stored directly inside the MFT. This is called as a resident data, and it helps the system open those files much quicker. This means this does not take a longer time. Now NTFS also has some advanced feature. That the first one is it supports journalizing, means which means it keeps a log of changes. This helps prevent the data loss if your computer crashes. Now the second one is security. It provides the access control list which let you decide exactly who can read, write and run a file. Now third one is compression and encryption, that is EFS. It includes compression and encryption, which helps save space and protect data. So overall, NTFS, that is a new technology file system, is secure, reliable, and efficient. That's why it is the standard file system for the Windows. Now the Linux standards. Okay. Now that we have talked about Windows, let's move to the next slide, that is Linux side. Linux uses open source file system, which means anyone can improve or modify them. We will start with the most common family called the ext family and see how it's evolved over time. Linux, the ext family. The most popular file system family in Linux is the ext family, which stands for Extended File System. It is gone through several versions, that is ext2, ext3 and ext4. The first version, ext2, was very stable and used something called inodes to store information about files, but ext2 had one big problem, that is it didn't have journalizing. So if your system is crashed, you could see lose data, or have to check the whole system before rebooting. To fix this the problem, ext3 was introduced. It is basically ex2 but the journal file added, that is absent in ext2. That made it much safer. If the system crashes, it could quickly recover using the journal. Finally, we have ext4, which is default in the most Linux system today. The biggest improvement here is the something called extend. Earlier, each file had point to every single data block, which is inefficient. Extend solve that by grouping continuous blocks together, which make it much faster or larger files can reduce fragmentation. In short, ext2 is a simple and fast, but no generalizing. ext3 added generalizing and more reliable. ext4, the fastest, most efficient, and great for big files. So the ext family shows how Linux systems have evolved, become more powerful and reliable over time. Next one is modern controllers, that is XFS and BTRFS. After ext4, there are two powerful file systems in the Linux world, that is XFS and BTRFS. Both are modern and come with their own special advantages. Let's start with XFS. You can think of XFS as high performance workhouse. It has been around for a long time and is known for handling very large files, even in terabytes. Its main focus is on high performance, scalability, and parallelism, meaning it can handle many read and write operations at once. That's why XFS is often used in media server, scientific computing, and large enterprise storage. Basically, anywhere huge amount of data needs to move quickly. Now, let's talk about BTRFS, which stands for B-tree file system. This is more recent and is being a next generation Linux file system. BTRFS focuses on data integrity and advanced features. Its most important idea to something called copy on write or COW. Here, how it works. When you change a file, BTRFS doesn't overwrite the old data. Instead, it writes a new data to the new block. Only after it's safely written does it update pointers to the new location. This keeps your old data safe until the new one is fully stored. After that, old block is marked free. Now, here is the benefits of this approach. First one, no generalizing need for crash safety. First, you get great crash protection without needing a traditional journal. If your system crashes while writing, all data is still there. Now, second one is near instant snapshots. That is, BTRFS can make instant snapshot. This means it can save the current state of the file in seconds. Very useful for the backup. Third one is built-in array ID, data scrubbing, and checksums. It has advanced feature like built-in array ID and it automatically checks data for error using checksum, which helps prevent silent data corruption. So in short, XFS is a perfect for speed and handling big data, while BTRFS is amazing for safety, flexibility, and modern features. So this is all about the NTFS, that is New Technology File System. Next one is a Linux standard. And the next one is EXT family. That's EXT2, EXT3, EXT4, and then some modern controllers, that is XFS and BTRFS. So next part will be explained by the Aditya.
Hello everyone, I am Aditya Dabade and today I will explain the network file system. In this network file system, the most important thing we can see on these slides, the NFS is a protocol, not a disk format. In We cannot format a drive as NFS. It is standard language. The concept is a distributed file system of protocol that allow a client to access the distributed file in the computer. To access We can access this file over a network as like a local hard disk. How it works, it wa- a server which we can which be running by xfs. It is export to the one of its local directories and making it available of on the network. A client machine then mouse the remote expert. The client as OS translate local system calls. It reads into NFS request to all these applications on this client. They can remotely direct just looking like another level of the folder. When you double click, then the file of NFS uh, of this client is translate into read. Then we can call it as NFS request. Then send it over. Then send it the network to our server, and the server send the data will be back. The most common part we can use case for the centralized home directories in a university or corporate environment. In this, we can allow the log of any computer in the labs and see we can uh, see the same desktops and document folders like machine just mounting your home. Next slide is file system comparison. In file system comparison, we can look primary uses, key methods, reliability, security, and key features. In primary uses, we can see the clear separation, FAT compatibility, NTFS for Windows, ext4 and BRTFS for Linux, and the NFS for the system. In this key method, we can see the technical hertz. We will we will simple link the list in FAT uh, to the database MFT are present in NTFS. We can efficient the node and extend the model in ext4 and the new copy of and the new copy on right uh, pragri- uh, padigram of BRTFS. Next one is reliability. In reliability, this is a critical fact. Fat has it has no fat. The other have reversed situations, either journalizing and copy on right. Next is security. In security, there are another huge gap. Fat will be not. NTFS has powerful gen granule CLS. In Linux system, we can use the standard POSIX permissions, and NFS has its own security model, like Kevros. And the last one is key features. In key features, we are seeing FAT32, its compatibility, and next is NTFS. It is a general security for database like structures. Next is ext4. It is a speed and stability. Next is BRTFS. It is a snapshot and integrity. And the last one is location transparency. In location transparency, it is a NFS like making remote files. Uh, Next one is conclusion. In conclusion, we can see the file systems are complex and critical for OS abstraction. We can check the file system, and it is far more complex and critical part for operating system. It can be most people release. In this foundation, we can store the data and reliability. And in these key takeaways, we can entire uh, presentation. The best file system depends entirely workload. There is a no single right answer. For our OSD drive, we cannot balance speed and reliability of NTFS of Windows or ext for on Linux. For a critical file server, we can strongly consider BT, RFS, or ZFS for their data integrity and features of snapshots. For high through output media server, XFS is an excellent choice for this. And the external drive we can you can need to share with everyone. FAT32 or EXFAT is still to the right tool for the job. In this feature, we will see the file system continue to involve. They are becoming more. They are tightly integrated with the hardware like speed SSD and their continued growing focus of this data integrity. The features like becoming standard and the fight against silent data corruption. Thank you.